Hi, it's Clark on Temptress. Today we're going to look into this battery. This guy's got a few issues and we're going to try to figure out what the heck's going wrong with it. A friend bought this battery and it failed. I don't know the specifics of how it failed, but he says it's dead. Don't think bad about this company in particular because he contacted them and they stood behind it, sent him a new battery and said, keep the old one, we don't want it, it's not worth shipping. So he's got a dead battery and he knows me and he thought I might be able to figure out why it died. He'd like to know. I'd like to know. I'm assuming some of you out there would like to know. And why this could be useful, we'll dive into this, and if we can figure out how to fix it, if you either end up with a battery that's not performing and you get a replacement, or probably more likely, like a friend falls into that category and just doesn't know what to do with its carcass, maybe you can take the battery and turn it into a useful battery. Anyway, let's find out. We're going to dive into this and we're not going to stop until we have a working battery or know why not. First step, I'm going to take my voltmeter here and I'm going to set it for DC volts and just check it. Let's see what we get. .03 volts, so close to zero that it's dead. I'm sure my friend tested that, so I expected that. Now the next thing we're going to do is sometimes battery chargers, and I know this guy just has regular battery chargers, they won't charge a dead battery. They'll do some testing first. They're trying to be too smart for their own good, you know, trying to protect us from being stupid. And they just won't apply power when there isn't enough voltage to start with. Well, I'm using my bench power supply and it's designed to not be that smart. So we're gonna hook it up, turn it on here. I'll set it for 13.4, that's good. And we set it on and we get no flow of amps to speak of. We got 0.01 amps. So it's not taking power. So something's going on inside this case. And honestly, that's all I can do from the outside. So it's officially not working. I'm going to tear the top off it and come back to you because that's kind of boring. And we'll find out what's going on the inside. Well, that was easy. These things can be a real bear to get off. And sometimes I have to actually destroy the case. This one popped right off really, really easily. I haven't looked inside yet. I just popped it free. Also, it doesn't weigh much. You know, it weighs half the weight of a 100 amp hour. Let's remove the metals because we're going inside now. We don't have the protection of the BMS anymore. And looks like I'm safe. And here we go. I'm gonna move this camera so you can look from the top. Okay, that ought to do. Let's see what we can find. Well, we got two wires going to a itty bitty little BMS. It does have cell sensing. Looks like that's the thermal pickup. So let's start by using the meter and looking what the cells are doing. How a BMS affects things is it shuts off with transistors the negative side. The positive side is connected right to the series of cells. So I'm going to hook my meter onto the positive side here. It's easier to do here, I guess. Okay, and then we'll probe around with this side. Okay, to the pull side, I'll just do it again just to do it. And just as dead as it was before. Let's see, maybe I can share this with you. Yeah, okay. Now I'm gonna look at the cell side and we have 0.9 volts. Still pretty, really crazy low. I was hoping I would see like full voltage on the cell side and that would just mean the BMS is out. But with the cell voltage down, that tells me there's something really low on the cell side. And lithium is really, really touchy. If you take a cell over the voltage, you know, it's over its range, it will vent inside, open up some valves, let out some gaseous electrolyte, and that's all over. Well, in very short order. Also, strangely enough, if you totally discharge it, it's all over. So that's the BMS's #1 job. In fact, I think I'm going to do a video or two on just what a BMS is and what it does, because I think there's a lot of misunderstanding about what they do. And we're going to be living with these batteries for a while. They're really good. They all have a BMS, and let's see if we can get rid of some misconceptions about what they do. But that's a different video. Comment below if you want me to do that video and how deep you want me to go into it, because, well, comments help my channel, but also I'd like to know what people are interested in. I think that'd be a good one. All right, anyway, again, nothing. I have 1 volt, but not enough. I'm gonna apply some power directly to the cells. Again, I can hook the power supply right to the positive terminal, because that goes right to the cell. And then I'm gonna just touch it onto the cells here. I'm just gonna do it for a very short time. I'm gonna watch the amp flow at 0 amps. Okay, 5 amps went somewhere for a little while. Let me check this now. Yeah, the voltage came up to 3 volts, but it's going down pretty fast. Let's try it again. In going directly to the cell and bypassing the BMS, it's now my responsibility to not overcharge this. Actually, I can hook this back up with a clip so I can watch in real time what the voltage is, kind of sort of close to the cells. There's a lot going on with voltage drop and such, and I won't go into the details of it, but this will be informative, at least, to have this information. So 3.7-ish, and when I go on to it with this, I get a big spark, 5 amp spark, and 5 volts and going up. This is really, really low. With a set of 4 cells being that low, it kind of means, you know, like a 1/4 volt per cell. That is definitely in the dead range. It's possible that 1 cell is dead. So we won't go too terribly high here, but since it's taking current, I kind of don't think a cell is dead. Well, gonna learn more as it goes. Still taking 5 amps. Voltage is still pretty low. I think I'm going to stop this for a while. And the voltage is coming back down. I think I'd like to pull the cells out so we can look at the individual cell voltage. So let's go with that. Turn that off. Okay, it's glued in. It's usually really, really hard to get the cells out of these things because, well, you know, they're glued in every different which way and they're kind of heavy. But this little guy doesn't seem to have that much glue on him. And his cells aren't heavy. It's probably like, I don't know, 10 pounds. One thing about these little cells, I can tell right now, I can't pull on the wires. It would break the terminals right off. They're just little tabs. I think I have to use a tool. Remember, whenever you use any tool, any metal, screwdriver, whatever, you got to be extra careful because if you short it in a lithium battery, bad things will happen. These little foam bumpers here holding it all together, and if I just rip them out, that sounded promising. Okay. Lots of tape. There we go. Being very careful not to let anything short that shouldn't, but now I can get to the poles. So that's good. All right, back to our meter. So actually, this battery was not put together badly. They've got some insulated double-sided tape that held the circuit board on. This is fiberglass, and it's the PC type fiberglass printed circuit board. So it's very good insulator. So that protects all the cell caps inside. There's nothing that I see in this battery that says dangerous. You know, it looks like a reasonable little battery. Could just be bad luck. Okay, starting with, let's call this one cell 1. We'll start at the most negative. And we get half a volt. And then we'll go to cell 2, and we get a half a volt. Cell 3, 0.6, pretty close. And finally, cell 4, 2.4 volts. Well, isn't that peculiar? Okay. See, 2.4 volts is actually a reasonable amount of power, voltage for a discharge battery. The rest of them are very low. I think I'm going to charge the 3 low ones. Let's see how that works. I'm going to turn my, making sure that I have control of the tips here, because that'll get charged and 5 amps will flow through it. I'm going to turn on my supply here. And I'm going to set the voltage just a little lower. Not that it really matters. This can only put out 5 amps. The battery is sucking up the power, so this, you know, just won't like overcharge until these are more or less full and the battery lets the voltage go up. This is what happens so very often in the DC world. Our power supplies, we think, rule the roost. You know, our solar charge controllers and stuff, and we set them at a voltage. That's only the voltage that they're going to shut down at. They are going to basically be what we call, well, basically continuous current. They're going to say, here's all the current I can give you, and you do with what you may, and you're going to lower the voltage because you're just going to suck it up until it comes up to the point where we're starting to negotiate things, and then I'll start tapering. Okay, let me hook this on right here. So I'm only going to charge these 3 in series. Again, there'll be a little spark. It always scares me, even though I know it's going to happen. There we go. So we've got 5 amps going in. And let me watch the cells as I go here. Got a volt and a half, 1.3. Well, that was just the meter being turned on for too long. 1.3, 1.5, and again, this one is still at 2.5. Well, we'll let that cook for a while. Bring these lower cells up. We'll get them all up above 2.5. At that point, the BMS should actually power up. So we're going to jump ahead in time a little bit. I'll just let it cook here for a while. We're back. I was on the phone with a viewer, and I swore I could smell smoke. So I ripped everything off and, well, I don't smell smoke now and nothing's hot. Let me check the voltages again. 2.3. Yep, get out of there. 2.25, 2.6, and 2.3. Well, they're all up into that realm now. Let's do a quick test of the BMS and see if maybe it turned itself on. Yeah, I think I just imagined that smell because there's nothing hot, everything's cool. Okay, back to this now. When you have a battery open, you want to be cautious. You want to err on the side of cautious because these things can put out some real power. Okay, quick check here at the poles, and we have a bad connection. We have 9.4 volts, and on the outside we have pretty much nothing. So the BMS did not wake up. I'm going to keep charging it. This time the cells are all about the same, so I'm going to charge all 4 cells. And again, bypassing this. So let me put my sensor back on. This time I'll put it on the whole pack. Okay, here we go. Spark. Not as much of a spark because the voltage is higher now. Still charging at 5 amps. Up to 10 volts. Whoops. Yep, good. Okay, let's put some more power in it. We're putting 5 amps into what was a dead set of cells, and it's a 50 amp hour, so by rights, full charge should take 10 hours. So we got a lot of time before this is going to get dangerous. Assuming something isn't wrong. So far I haven't learned much, but I'm learning. The cells seem to be taking a voltage. We don't, I didn't let them set for hours, so I don't know if they'll hold it. I'm going to try to charge it up like sort of a quarter. The fact that the BMS didn't turn on tells me maybe the BMS is the problem for this whole deal. Anyway, give it some more time. You take a look on Amazon while I'm waiting for it to charge and see what a 50 amp BMS costs. Okay, some time's gone by. I've charged the cells up probably about halfway, and then I've disconnected them from the charger, and they're holding pretty close to 13.2, 13.19. They're not really, fully charged, so that seems reasonable. I'm going to go through the cells now and check their individual voltages, and if they're all still pretty good, I'm going to say the cells are good and the BMS is bad. In which case, I'm going to buy a new BMS for this because this is only a little 50 amp BMS. You can get them from, $8 or $9 up to like 15. Well, you can pay all you want, but I've seen some pretty good looking ones for like 15 bucks. So I think I'll buy a new BMS, put it in here, put the case back together because I didn't have to ruin the case to get it apart, and I'll have a 50 amp hour battery. I kind of like having a little battery like this because it's so very light, and sometimes you just need some mobile power, and like 10-ish pounds, you don't even think about it, you just have it available to you. So I kind of like that. Anyway, that seems to be the BMS. Oh, by the way, I found what I think is this BMS on eBay, and it was like $3. So yeah, there's probably a reason why it died. Well, that's about it on this battery. I'm Clark from Temptress, and I hope you enjoyed spending a day on my bench and tearing something apart. The cells are the valuable thing, the BMSs are cheap. It's almost always worth tearing into these things if you want the cells.